to use a metaphor, this diamond coal metaphor, to kind of highlight this idea. So, you ask yourself, how are these things different, this diamond and coal, and you say, well, one's high value, one's rare, one's beautiful, the other one's a commodity, it's plentiful and not so special, okay? But yet they're really the same, they're both forms of carbon. So really what's the difference? And the difference is the circumstance in which they were formed. High pressure, high temperature, and time realign the atoms into a different crystalline structure, and we have a diamond now that's rare and beautiful. So it's really the circumstances, really the difference. Now apply this metaphor to your people, okay? We all know people, we have people in our organization that are very capable. They make great decisions every single day. We can't imagine not having them. In fact, we want more of them, okay? High value contributors to your business. You also probably have some new shop floor employee that's inexperienced, and you maybe have less confidence in their ability to contribute to your business. They're different in our eyes, but they're the same in terms of what they are. They're both human with hearts to feel, minds to think, eyes to see problems. They both have great, they have the same makeup. So the question is what's the difference? And again, the difference is the circumstance in which they are formed, whether it be their upbringing, their education, their opportunity, even time at the business. And so as leaders, if we want to accelerate our improvement cultures, we got to realize we have great people, and we have that each individual in your organization has the potential to do really, really good things. We just have to create that environment or that circumstance where they can be successful. Let me give you an example of this. Let me tell you a story. I used to be a product, R&D engineer and product manager over the worst product line in our company. Had the worst yields, the worst margins, the worst on-time delivery. It was just the worst product. And so as myself and two other engineers, we had about combined, 40, 45 years industry experience. We knew our stuff. We knew the technology. We knew, how to design products. And we worked really, really hard to try and fix this product line. Okay, we fielded calls in the middle of the night. We went in the middle of the night. We were doing all sorts of stuff to try and fix this product line. You can see this graph represents our yields, our yield improvements for 3 years. Okay, we didn't make an ounce of difference in 3 years. 3 trained engineers didn't do anything. Okay, that's pretty discouraging. Okay, the product flow was a typical batch and queue, manufacturing process, 3 different departments. Things moved in large batches, sat in inventory. Flow time was about 4 or 5 days. Okay, that was kind of the process surrounding this, and we didn't make an ounce of difference. And then we learned something. We learned the principle of flow, and then the circumstance changed. We created a new circumstance of flow where we had product velocity. Okay, and we created this environment where one individual would do the work of 3 departments, one piece at a time. Now the cycle was a 10-minute flow time. Okay, we went from 4 days to a 10-minute flow time, and now all of a sudden everything changed. All of a sudden, cause and effect became apparent. Root cause, we could actually see root cause. We had high velocity, product feedback, and everything changed. And as you can see, the yields improved about 7% in less than a year. And the engineers, we didn't do anything. The shop floor employees improved this product line in less than a year, at a way better rate than we did as engineers. And the only difference really was, it's not like we taught them anything new. It's not like we said, hey, you got to solve this problem. All we did is change the circumstance. We created flow, and people immediately and naturally said, I'm going to fix that. And it was simple stuff. Our worst reject code was called dent and diamond. Basically, the mold gets dented, and then the diamond would have a dent in it because the mold got dented. And we could not figure out where these things were coming from. And it was as simple as the operator would go, oh, you mean if I drop the part, it matters? Oh, okay, oh, you mean if there's a particle in my pre-pressed mold that imprints on this mold, that's a problem? I mean, simple stuff that as engineers we couldn't ever be there enough to see, okay? But because we created this new environment, people could see these problems and they naturally solved them.